sir. And now we would move to our next session on global case study on standards-based deployment. I would like to now invite Mr. Phil Beecher, President and CEO, Wyson Alliance, to present standards-based deployments of applications and utilities. Mr. Phil Beecher is the President and CEO of the Wyson Alliance, an industry organization which promotes standards-based interoperable wireless communications products for smart utility networks, smart city and Internet of Things applications, and implements a rigorous testing and certification program to achieve its aims. He has been an active contributor in the development of communication standards and the specification of test plans for a number of smart utility network standards, including advanced metering infrastructure and home energy management systems. Sir, the floor is yours. Request Asif to give presenter rights to Mr. Phil, please.
Thank you. Hopefully you can hear me.
Yeah, in here, sir. Given the right.
And hopefully you can see my screen now.
Yes, right, sir. Thank you.
Yes, we can.
Excellent, thank you. So firstly, thank you very much for the opportunity to speak today. I'm going to be speaking a little bit about Wyson Alliance, which is the organization I've been involved with for about 10 years or so, and then give an overview of some of the case studies that we've experienced within Wyson. So firstly, an introduction to Wyson. We are an industry alliance, a global ecosystem of member companies whose role is really to seek to accelerate the implementation of open standards-based field area networks and Internet of Things solutions. So communication infrastructure for large-scale networks such as those used by utilities and smart cities and smart communities. So we support a number of applications that enhance efficiency, quality of service and resilience. These are the utilities such as advanced metering infrastructure, which include things like peak load management, distribution automation and smart metering. Other smart city and smart community applications such as street lighting, infrastructure management, smart parking, environmental sensing, traffic and transport systems, smart homes, particularly with related to energy management such as thermostats, air conditioning systems, and energy usage displays, and other M2M applications. So Wyson Alliance started off really for the utility industry and the smart cities, smart communities, but we're seeing a growing adoption of the technology in things like agriculture. So we now have over 300 member companies representing some 46 countries. Let me talk a little bit about the international standards involvement. So I got involved in this topic way back in, well, before 2008. And at that time I was working for a silicon vendor, semiconductor vendor. And at that time, so some of the larger US utility companies were looking at smart meter deployments. They included Pacific Gas and Electric, Florida Power and Light, but they saw that there was no single interoperable standard that would provide them with the ability to give an interoperable wireless communication network for peer-to-peer connectivity. And there were a number of solutions already available from a list of companies as shown here: Archrock, who are now part of Cisco, Cyan and Conode, Elster, Itron, Landis+Gyr, Silver Spring Networks, who are now part of Itron. And they all use similar technology, but they were not interoperable. So therefore a standard was needed. So we went ahead and worked on the standard that became 802.15.4G, and it was optimized for large-scale outdoor networks, so field area networks. And part of the goal was to take proven technology to create the standard to meet the needs and allow global interoperable products that could be deployed globally. So that standard was first published 2012 and then included in the 802.15.4 revision in 2015. So it took advantage of the proven technology. It is backwards compatible with an installed base of tens of millions of meters. And then that was further extended by a number of amendments, including 802.15.4U, which targeted the 865 to 867 megahertz band in India, and then other amendments to look at other global domains and to enhance the security. So now 802.15.4 supports a whole range of global and regional frequency bands. So if I describe a bit about the Wi-SUN technical profiles, there are two really dominant profiles within Wi-SUN. There's the field area networking profile, which is shown on the left. So this specification has been approved for several years now. It uses the 802.15.4G technology along with 6LoWPAN IPv6. It supports multi-hopping operation for mesh routing and frequency hopping for improved interference immunity. The security supports AES encryption for the frames, and we use another IEEE standard 802.1x for device authentication. And then this specification has been standardized as IEEE standard 2857-2021 and an ANSI, which is the American National Standards Organization, 4957. We now have around 49 certified products from 20 vendors. We also have the home area network profile, which again uses the same underlying communications technology, supports the same encryption, and the authentication mechanism is different. And that's been very strongly adopted in Japan for the connection from smart meter to home energy management system. That is also standardized as a Japanese national standard as TTC JJ300.10. So let's talk a little bit about testing and certification. This is talking about the benefits of FAN certification, but I think it holds for all standards-based devices. But basically, if you certify a device and if as a customer you use certified devices, then you have access to a large ecosystem of devices, which brings less risk. You have access to standards and interoperability, and the solutions will be non-proprietary. This means that it improves cost and time to market and provides for new features. So as I mentioned, we have a significant number of certified products for field area network, and these include communications infrastructure devices and smart meter connections and modules from companies such as Cisco, Itron, Landis+Gyr, and Cyan Conode, as shown here, and a number of silicon vendors as well. So there's quite a large ecosystem of products available. On our website and on YouTube, there is a demonstration video of interoperable products. So we first showed this demo at Distributech in 2020, and since then we've produced a video and we continue to add to the products showing on this video. So putting it into practice, within Wisum, we've had very strong support from utility companies. Here on this slide is a list of those utilities who are Wisum members who have contributed or participated in some of our developments and testing and certification program. So if I go in and just highlight a few. So this slide shows field area networking for grid modernization from Hawaiian Electric Company. So as you can see, there's a lot of content on this slide. I won't go into all of it, but their view, Hawaii is planning on deploying 100% renewable generation by 2030. As a result of this, they need good communication systems for grid control. So this is their modernization program is not just about smart metering, but also distribution devices such as secondary line sensors and volt bar power controllers. And the metering and distribution field devices are part of a common Wisum network. And then the applications that need high bandwidth or low latency can also be part of the same network, and then they will communicate using Wisum FAN, but also connect into the wider area through either fiber or cellular or other options. Then as they grow this, they would also look at adding things like secondary bar controllers that can receive alerts from the AMI network and automatically make adjustments. And there is another standard. So as I mentioned, Wisum FAN is the communications layer. There is another standard that they're using called an Open Field Message Bus, which is shown at the link, and that is a standard that's been adopted by the North American Energy Standards Board, NAESB. Another example is with Iberdrola and Avangrid, who have been working with EPRI, the US EPRI, the Electrical Power Research Institute. And they, again, is a case that even though there is the desire and the goal for interoperability, up until fairly recently, the interoperability between smart meters, head-end systems, DCUs, etc., was an unrealized goal. So the work that's been done by Iberdrola and EPRI and Avangrid is to develop an interoperable protocol stack, which has a number of physical connection layers, which I'll show on the next slide, but primarily is DLMS COSEM at the application layer, and then using an IPv6 transport, whether it be Wisum FAN or power line carrier, as shown in this diagram here. So Iberdrola is the national utility for Spain. In Spain, they deployed something like 11 million meters, interoperable meters using 9 different product vendors, and they are primarily DLMS running over prime power line carrier. In the UK, they have deployed something like 1 million meters using DLMS. This is primarily on a cellular network. Then for Avangrid in Minnesota and Connecticut, they are using DLMS again as the application layer, running on Wisam FAN, and New York is looking at deploying something like 1.8 million. So there's currently 875,000 deployed in the smaller states, and the deployment is underway with 1.8 million. And that's primarily electric at the moment, and then there is some work going on in Wisam Alliance for interconnection of gas meters into the same network. Then in Brazil, there's a pilot trial going on using DLMS, again, as the common factor, and that is a mixed network with Wisam FAN for wireless mesh connection and Prime for PLC. Another example is from Korea. So Korean Electric Power Company is looking at deploying a fairly large network integrated IoT with smart meter technology and other IoT devices on the same network. Again, this will be a mix of communications technologies, power line, Wisam FAN, and they are using lightweight M2M as the application layer, and this was connected through a Pelion IoT platform. The City of London, so not necessarily smart metering, but still energy management. City of London has done a upgraded street lighting project where they replaced outdated lighting with LED lighting, and at the same time it included wireless mesh communications, so Wisam FAN into the street lighting network. Now, I think there's something like around 12,000 street lights, which include street lighting and architectural lighting, so things like St. Paul's Cathedral and the Millennium Bridge. And you can see some more information on our website at the link shown. So those are just a number of the use cases that are out there that we've seen, and I think that the common aspects of these are that they're all using open standards technology, and open standards represent the basis for interoperability. And interoperability delivers vendor choice, so you have a choice of where you buy your products from, cost savings, obviously, because if there's choice, then it becomes a competitive market. It reduces the risk because there are multiple vendors. The organizations such as Wisam or G3 PLC or Prime will do rigorous testing to ensure interoperability, and this improves time to market. So it makes it much easier for the utility to know that a product's going to work and be able to deploy it without necessarily having to do long-tailed pilots. And it also provides the ability to add new features. So, for example, within Wisam, we have a number of module vendors who can provide a communications solution, and then that communications can be integrated into new devices, new field devices, for example. So with that, I'd like to thank you for your attention, and hopefully this has provided some interesting views for you. Thank you.
Thank you, sir. I would now like to invite Mr. Kaustubh Patil, Lead Technical Architect, Secure Meters Limited, to present standards-based deployment of applications in utilities. Mr. Kaustubh Patil is currently working as Principal Technical Architect at Secure Meters Limited and is responsible for product development, encompassing safety compliance, reliability engineering, EMI, EMC compliance, and local regulatory compliance of products according to the end market needs. He has been instrumental in building an in-house team with expertise in low power radio designs, cellular-based solutions, power line communication solutions, etc. So the floor is yours now. Request Ms. Sonia to bring up Mr. Patil's slide deck, please.
Sorry, I was muted. Thank you for giving me this opportunity of bringing our experience of the smart meter rollout that Secure has done in UK and Australia. Next slide, please. Yeah. It is a matter of great privilege to share our experience of running AMI system using cellular technology to the wider audience. I'll be talking about what challenges we have faced and circumvented, and what learning we can carry forward for the deployments in India. Cellular technology is one of the most researched technology developed and standardized, such as to benefit across multiple geographies in multiple applications, and provide benefit due to the scale and the scalability it offers. When I'm talking about the experiences, I just want to bring to everybody's notice that Secure, we have global AMI and AMR experience with close to 10 million products or meters connected on cellular technology alone. The 6.6 million smart meters, as it is being shown here in the UK, all are on cellular technologies. That is not mentioned in the slide. Next slide, please. So this experience and the learnings that we have gathered, it comes after running the system for more than 8 years, running the system with more than 34 energy retailers. Rest figures, statistics is 72 million U-Trans, 66 million SMS messages, 140 million alarms, all gathered over the cellular network. The overall meter reading success is close to 98% on scheduled data collection basis. Next slide, please. Yeah. Smart metering is a system with combination of meters, communication network, head-end system, and meter data management systems. All these things provide a sea of opportunities for the enhancement and improvements in advancing our energy infrastructure. With the diverse geography that we have and the rural and urban install base of electricity meters, the cellular technology offers a couple of benefits, but now I would like to talk more about the challenges and the way we can actually overcome it together. Next slide, please. So the challenges that we noticed and we faced were ubiquitous coverage of any cellular network technology by the communication service provider. This is difficult to achieve. We all have been using cellular phones for quite some time, and all have noticed not spots in couple of places. But there are ways of actually addressing these challenges. Vast improvements in the field of cellular communication results in upgradation of networks, services, and old technologies becoming obsolete or non-viable to maintain. Networks' priorities and preferences to service high revenue streams, voice and data. Presence of not spots indicating that no signal available. And signaling storms in the network due to uncontrolled behavior of M2M devices. As we all have noticed that everywhere the expectations are of SLAs and high demands of timely deliveries of the data, there is always the risks of devices being aggressive to push data to the system, even if there are some glitches in the network. This causes signaling storm onto the networks. Next slide, please. So the recommendations based upon our global case studies, learnings that we have gathered, which we would like to present here and bring to everybody's attention. Virtual network providers and or intra-circle roaming. This can help. This will help the M2M devices to latch onto a network with optimum signal and a network performance. Further, eSIMs with EUICC can enable easy installations and change of CSP to ensure that the M2M assets endure service for their lifetime. All the activities, work that is going on in the AMI domain, we are looking at a minimum horizon of 10 years field life for the assets which are being deployed, and hence the changes to the cellular network community, they have to be addressed. The technologies which need to be deployed need to endure time and should be in continued roadmap of 3GPP, which are the governing bodies for the specifications of the cellular technologies, current and upcoming. NB-IoT, which will continue to be served from 4G into 5G deployments. That is the recommendation or the learning that we have gathered. Technologies such as NB-IoT, which operate on sideband, do not cause network congestion, causing interference to the consumer services. Now, this actually, one, with the peak demands in the cellular technology or the usage during the festival seasons, tend to choke the cellular networks. But if you are using a spectrum which is not being shared with the consumer services, the assets which are deployed, they will not face any restrictions on the bandwidth that is required for them to operate. As we all know that if we are in closed rooms, remote places, we often have quality of call challenges. The NB-IoT, by the technology itself, offers a 20 dB benefit over the penetration compared to 4G Cat1 services. Looking at our rural infrastructure, availability of networks, a 20 dB gain in the penetration and the reach is of huge importance. reducing the challenges the installers will face to commission and repeat visits to the site to ensure that the systems are brought into working networks. The GSMA Association has provided with connection efficiency guidelines. The challenge that I mentioned about the signaling storms which can cause congestion to the cellular networks. To overcome that, the GSMA has come up with efficiency guidelines, which, while implementing for a mass deployment like this, will prevent any adverse effect on the consumer deployments. This is all that I wanted to share. I would like to thank everybody for giving me this opportunity of sharing our learnings on cellular technology in AMI domain for the benefit of the wider audience. Thank you.
Thank you, sir. We would now like to open the floor to questions. Thank you, sir. We would now like to open the floor to questions. I request Mr. Ajay Nain from DOT to please read out any questions that may have come from the audience.
Whether that DIMS protocol has very large payload. So if we are testing this over NB-IoT, it becomes very difficult how to optimize that. Sir, then how can we manage this?
Mr. Phil, this question is addressed to you.
Okay. So I think.
Sorry. Sorry, I had a network glitch. I could not hear.
Okay, so I think this question was addressed to me, but actually I think it should also would be a good opportunity for you to answer this as well. So I think as you so the questioner is asking about the fact that DLMS protocol has a very large payload, and I think that the problem is going to be the same with all communication technologies, in that when you have a large number of devices that are trying to communicate, there is always going to be a limited bandwidth unless everything's connected on fiber. So that becomes a problem. And I think that this is one of the functions of the DCU, is that if you can use a DCU to do store and forwarding, then it gives you the opportunity to do data concentration locally. So I think also my view on this is that there are distinct benefits on using a mix of communication technologies between the smart meter all the way to the head-end system.
Thank you, Phil, for answering. I would just like to add one more thing. It would also help us in actually scheduling the data push from the meters, such that we ensure that we do not load the networks throughout the day. We schedule the activities in the quiet periods, such when the load on to the cellular networks is reduced, typically in the late nights, and use the daytime for on-demand and control activities.
Thank you, sir.
Regarding the
Yeah.
Regarding the question, I just saw in the chat, DLMS protocol has very large payload. So if we are testing this over NB-IoT, yeah, the answer to this is DLMS also has a mechanism of data push based upon events. And if we are doing the event based push normally and transfer the DLMS data when the load onto the networks is reduced. So we need to do more of scheduling.
Thank you, sir. Mr. Nain, is there any other question?
Ma'am, there is one more question from Mr. Neeraj. The question is to Mr. Maninder Mohar, sir.
Mr. Nain, we're not able to hear you well.
Sir, the question is, what is the future scope of service providers like O&M?
Hello?
I think Mr. Nain has some audio issues.
Okay. Okay, so I think the question being referred to is for Mr. Maninder Mohar from the previous session. This is from Mr. Neeraj Dhawan, and he's asking, what are the future scope for service providers like O&Ms? Mr. Mohar, if you are here, would you like to answer that question, please? Okay, then I think we will take this offline. Another question that which I can see are related is that from Mr. Abhi Sabru is will all the slide decks shown here be shared with participants? So the slide decks will be shared upon taking due approvals from the speakers on the TSDSI website in a few days, and we will provide the links, etc., in the thank you mail, wherein you can access these from the website. Any other questions?
Yes, Shefali, this is Bindu. May I come in just for a minute?
Yeah, sure. Please, Bindu.
Thank you. So the question from Mr. Neeraj Dhawan on is there a, if I got that right, is there a scope for O&M service providers in the kind of services that were being talked about for water metering, and if you can extend it to utilities? We did not have a speaker from the gas sector, but in general, operating, monitoring the water, gas, and electricity. Is there scope for O&M operators or O&M service providers also? So if any of the speakers who are available, if any of the speakers would like to please comment on that. Thank you.
Maybe I could briefly answer that. So I think the short answer is yes. And if you look at, if one takes a look at sort of the global environment here, depending on where you are, depending on the economics of the situation, there are quite often benefits for either a utility or, in the case of cities or smart communities, in using a O&M provider to actually provide the services. And that could either be a public organization or it could be a private organization. So I think the answer from my point of view would be yes. And there are places where people will do this.
Thank you, Mr. Beecher. And that could be extended. The O&M service providers, they could use some smart IoT M2M technologies, for example, in field force automation or some such things, some such use cases to make their services more efficient. Do you think there is scope there?
So I believe so, and I think this is another reason why using open standards and interoperable solutions becomes beneficial here. And certainly when one starts looking at cybersecurity type specifications, because it's quite possible that a company will want to provide multi-service support for a number of different customers. So there needs to be the opportunity to keep those well segregated.
Absolutely. Thank you very much.
Thank you, Mr. Beecher. Thank you, Mr. Patil, and thank you, Bindu. I would now move on to the next session that we have on India context, standards-based deployment showcase. I would now like to invite Mr. Deven Babubhai Patil, who is the head of energy analytics at L&T Smart World and Communication, to present on EES